On the other hand, we have the DNS suffix. The DNS suffix is the DNS domain that is appended to all unqualified name queries or a query that contains only a host name. Especially in environments with multiple domains, adding the domain suffix can ease the burden of communicating with clients in other domains without a fully qualifying name. DNS suffixes are very helpful for resolving fully qualified domain names when only a host name is specified. However, if you perform an NS lookup query, the Windows DNS client will append the current DNS suffix to the action. To prevent this, you should do not terminate or dot terminate your fully qualified name, or add a dot to the end of the fully qualified name. The dot termination is not necessary if you're resolving unqualified names for domains with DNS suffixes. You're actually going to be adding a domain suffix to your IP properties in the activity 5.6, and you can find the instructions of how to change the DNS suffix in page 178 of the book. For Server Core operation of Windows Server 2008, changing the DNS suffix is more complicated. Unlike the other properties for a network adapter, Server Core does not support changing the DNS suffix with Edge. You have two options. If your Server Core installation is a member of a domain, you can use group policy to apply the DNS suffix. And the next option is to edit the registry using the regedit.x. But honestly, that's not the best option if you don't know how to really edit your registry. DNS server types are determined by the type of zone or zones they host, and by the functions they perform. A DNS server may host either primary or secondary zones or both. If the server doesn't host any zones, it is referred to a caching-only server. A server is said to be authoritative for a particular zone if it hosts a primary or secondary zone for a particular DNS domain. To enjoy the benefits of DNS, you must of course install DNS. Before you install DNS, it is recommended that you configure your computer to use a static IP address. If the DNS server is assigned its IP address from a DHCP server, its IP address may change. If the DNS server IP address changes, queries sent by the DNS clients configured with the old IP address will fail. Windows Server 2008 provides several wizards and other tools to install DNS quickly and easily. One method of installing DNS is by using the Server Manager page. The Server Manager page enables you to add or remove server roles, such as file server, print server, DHCP server, and DNS server. DNS is a role that you can install on Windows Server 2008 Full and Server Core versions. Often, DNS is combined with other services such as DHCP, or in the case of Active Directory Integrated DNS, it is combined with a domain controller. As we mentioned before, a DNS cache only, it is simply acting as an intermediary for DNS clients in resolving DNS queries. Using the caching functionality of DNS, a cache-only server provides clients with query answer and stores the answers in case other client requires the same information. Cache-only DNS servers are a good option for workgroup environments that want to centralize the DNS request through a single server. In the activity 5.8, you're actually going to be installing your DNS server through a DNS role using the Server Manager. Besides the graphical interface, you can use the command line interface to install the DNS role. For the full version of Windows Server 2008, you can use the Server Manager cmd.x command line to install the DNS role. For the Server Core, you use the ocsetup command to install the DNS role. ocsetup is a command line tool for installing roles on Windows Server 2008 running the Server Core. When the DNS is installed on a full version of Windows Server 2008, the DNS console is available through the Server Manager and as a standalone in the Microsoft Management Console. The DNS console allows you to create DNS zones and manage the DNS server settings. For configure the DNS from the command line in both versions of Windows Server 2008, you can use the DNS CMD utility. The DNS CMD allows you to manage all of the DNS server configuration and management settings from the command prompt or a script. Also, you can configure DNS using Netsh. DNS server resolve DNS queries using local authoritative of cached data. But if the server does not contain the requested data and is not authoritative for the name in a query, it may perform recursive resolution or return a referral to another DNS server depending on whether the client requests recursion. The DNS server service must be configured with root hints to resolve the queries for names that is not authoritative for or for which it contains no delegations. Root hints contains the names and IP addresses of the DNS server authoritative for the root zone. You can use the DNS console to manage the list of root servers as well as the DNS CMD command line utility. By default, the DNS server uses the rootkit file called the cache.dns on Microsoft DNS servers. When the server starts, the cache.dns is preloaded in the server memory. By using root hints to find the root servers, a DNS server is able to complete recursive queries. This process is designated to enable any DNS server to locate the servers that are authoritative for any other DNS domain name using at any level in the namespace tree. When you use the Windows Server 2008 graphical interface to configure a DNS server, it sends an NS query for the root domain, that is that period that we were talking about, to the preferred or alternate DNS server for the server. The query response is placed into the root hints of the DNS server. If no root servers are detected, the wizard sends the same query to the DNS server specifying the cache.dns file that correspond to the root servers of the internet. If no root servers are detected, then the wizard prompts the user to either make the server a root server or to manually specify root hints. Updating the root hints enables the server to function more efficiently, so you should update the root hint whenever a new server is added or changed. On the other hand, we have the forwarder DNS. A forwarder is a DNS server on the network used to forward DNS queries for external DNS names to DNS servers outside of that network. A conditional forwarder forwards query on the basis of domain name. A DNS server on a network is designated as a forwarder by having the other DNS servers in the network forward the queries that they cannot resolve locally so that the DNS server can have a break. By using a forwarder, you can manage name resolution for names outside of your network, such as names on the internet, and you improve the efficiency of the name resolution for the components in your network. For example, to use forwarders to manage the DNS traffic between your network and the internet, configure the firewall used by your network to allow only one DNS server to communicate with the internet. When you have configured the other DNS servers in your network to forward queries they cannot resolve locally to the DNS server, it will act as a forwarder. Because external network traffic is going through a single DNS server, that server builds up a large cache of DNS data, which over time decreases internet traffic and provides faster responses time to clients. Without having a specific DNS server designated as a forwarder, all of the DNS servers can send queries outside of a network using the root hints. As a result, a lot of internal and possible critical DNS information can be expected to be exposed on the internet. In addition to these security and privacy issue, This method of resolution can result in a large volume of external traffic that is costly and inefficient for a network with a slow internet connection or a company with a high internet services cost.